Hello dear students, today's topic is reactions of phenol. The first reaction is the acidity of phenol, that is the salt formation. Phenol react with sodium to form sodium phenoxide by the loss of proton on oxygen. Though it gives proton in this reaction, phenol is said to be acidic in nature. Likewise, phenol react with a base like sodium hydroxide, whereby it loses a water molecule and gives formation of sodium phenoxide. Though phenol react with base and forms water and salt, phenol is said to be acidic in nature. The second reaction is the ether formation reaction. It is observed that phenol on reaction with sodium forms sodium phenoxide, which on reaction with alkyl halide like ethyl chloride gives formation of ether. In this case, the ether formed is ethoxybenzene, which is also called as phenitol. Let's look at the second example. Phenol on reaction with ethylene oxide gives formation of 2-phenoxyethanol. In this reaction, the hydroxy group of phenol attack on the carbon of the epoxide ring to bring about the nucleophilic substitution reaction, whereby it leads to formation of 2-phenoxyethanol. We can look here that here is the presence of the aromatic ring with the oxygen, and the rest one is the alkyl group. So AROR, that leads to the formula for the ether. The next reaction is the ester formation reaction. It is well known that phenol on reaction with acid chloride like acetyl chloride in presence of base like sodium hydroxide gives formation of phenyl acetate. Here the hydroxy group of phenyl attack on the carbonyl carbon of the acetyl group and bring about the substitution of the chlorine as chloride. So it is a nucleophilic acyl substitution reaction that leads to formation of phenyl acetate. Though HCl is liberated in this reaction is carried out in presence of a base like sodium hydroxide. Let's look at the second example. Phenol on reaction with benzoyl chloride in presence of sodium hydroxide gives formation of phenyl benzoate, which corresponds to the formula ArCOOAr. Here also HCl molecule will be liberated out, and to neutralize that, sodium hydroxide is included in this reaction. This reaction is a very familiar one and is commonly known as Schotten-Baumann reaction. The next reaction is the nitration reaction. This reaction takes place in presence of dilute and concentrated nitric acid. This is the example of electrophilic aromatic substitution reaction. The nitronium ion given by the nitric acid will get substituted for the proton of the benzene ring. In case when phenol is reacted with concentrated nitric acid, the product obtained is 2,4,6-trinitrophenol, while when phenol is treated with dilute nitric acid, we will get the mono-substituted product, that is either 4-nitrophenol or 2-nitrophenol. The major product being the 4-nitrophenol, which is due to the steric hindrance provided by the hydroxyl group. The next reaction is the bromination reaction. Like nitration reaction, the bromination also takes place under two conditions. When phenol is treated with bromine water, the product obtained is 2,4,6 tribromophenol. While when phenol is treated with bromine in presence of carbon disulfide, we will get two products, that is 4-bromophenol and 2-bromophenol. Being 4-bromophenol being the major product, while 2-bromophenol being the minor product. The next reaction is the sulfonation reaction. Here also we can observe two conditions. Phenol on reaction with concentrated sulfuric acid at 100 degrees centigrade leads to formation of 4-hydroxybenzene sulfonic acid. Here we can see that the sulfonyl group gets attached to the para position of the hydroxyl group. While when phenol is treated with concentrated sulfuric acid at 15 to 20 degrees centigrade, the major product obtained is the ortho one, and this product is called as 2-hydroxybenzene sulfonic acid. Let's go for the next reaction, which is the Friedel-Crafts alkylation reaction. Alkylation simply means the attachment of the alkyl group. Here the hydroxy group is the ortho para director. In presence of aluminum chloride, alkyl halide like butyl chloride react with AlCl3. The tertiary butyl cation will be formed as the electrophile, which get attached at the para position of the hydroxyl group to give 4, that is this fourth position, tertiary butyl phenol. The next reaction is the acylation reaction followed by Fries rearrangement. We had already seen that phenol on reaction with acetyl chloride in presence of a base like sodium hydroxide forms phenyl acetate. This phenyl acetate, when is treated with aluminum chloride, the acetyl group, that is CH3CO group, is get migrated to the ortho position of the hydroxyl group, and we get formation of 2-hydroxyacetophenone. The next reaction is the nitrosation reaction. Dear students, this word nitrosation simply means the attachment of nitroso group. Nitroso means N double bond O. When phenol is treated with sodium nitrite in presence of sulfuric acid, gives formation of 4-nitrosophenol, that is this product, and 2-nitrosophenol. Once again, the 4-nitrosophenol being the major product. One important point is that this sodium nitrite is used here to generate nitrous acid, that is HNO2, which is not isolated but is obtained in situ, that means during the reaction. That nitrous acid gives the nitrosonium ion as the electrophile, which then attack on the most active para position to form 4-nitrosophenol. The next reaction is the Kolbe reaction. This is a very important reaction. Phenol on reaction with sodium hydroxide in presence of carbon dioxide gives formation of salicylic acid. Here the COOH group and the hydroxyl groups are at ortho position to each other. In this reaction, carbon dioxide act as the electrophile and attack on the ortho position of the hydroxyl group. The next one is the Riemer-Tiemann reaction. This reaction takes place between phenol, potassium hydroxide and chloroform. Potassium hydroxide and chloroform react to generate a electrophile which is called as dichlorocarbene. That dichlorocarbene attack on the ortho position of this hydroxyl group to form the intermediate molecule, which then on treatment with water gives formation of 2-hydroxybenzaldehyde, which is commonly called as salicylaldehyde. The last reaction is the coupling reaction. Here this word coupling simply means the combination of two molecules to form a bigger molecule. Phenol react with benzene diazonium chloride in presence of a base. The diazonium group, being electrophilic in nature, attack on the para position of the hydroxyl group to form this product, which is called as para-hydroxyazobenzene, which is commonly referred as orange dye. This orange dye means that the product obtained is orange in color. So dear student, these are the reactions of phenol. Thanks for watching the video. Please like, share and subscribe. Thank you.